Okay, so we're going to do function operations and compositions. So what we're going to look at first is if I give you functions, can you do an operation between the functions? It's not hard, okay? So if I'm just adding and subtracting, so say I give you f of x equals 4x to the 1/2, and g of x is equal to negative 9x to the 1/2. Okay, remember that if I give you rational exponents, you work in rational exponents till the very end. Okay, so if I'm saying f of x plus g of x, then I'm taking whatever f of x is, which is 4x to the 1/2, and I'm adding it to the negative 9x to the 1/2. Okay, I put the plus with the negative in parentheses just for this first example so you see what I'm doing, okay? I don't want you to see a plus and then my work have a minus and you go back and not realize what I'm doing. Okay, once I have this, remember that you're looking at like bases and like indexes, right? Which is your root. Is that the top or the bottom of that rational exponent? It's the bottom. Can I add these? Are they like terms? Yeah, x to the 1/2, x to the 1/2. So 4 minus 9 is negative 5, x to the 1/2. Which simplified is just negative 5 square root of x. Okay. Now if I take f of x minus g of x, then I've got 4x to the 1/2. Now I'm going to have minus the negative, so that's going to turn into plus 9x to the 1/2. So what is that going to give me? 13x to the 1/2, which is 13 square root of x. Very simple. Okay, now could it get messy? Yes. But for right now, it's very simple. Alright, now multiplying and dividing, I'm still giving you the functions. So f of x is equal to 6x and g of x is equal to x to the 3/4. So if I'm multiplying, I have 6x times x to the 3/4. Well, how am I going to do that? So, do I have two x's? Yeah. I have a 6x and an x to the 3/4. This x has an exponent of 1. Remember, when you multiply like bases, even though I wrote it in parentheses, I'm multiplying like bases. I'm going to add my exponent. So, I'm taking 1 plus 3/4. So, that's going to give me 6x to the what? Okay, now I need to put it in radical form. Is that 6 going to be part of my radical? No. That exponent only goes to what is directly in front of it. That's why I keep emphasizing parentheses. If it's not in parentheses, then it's not part of your base. So now we have to broaden. It's no longer just applying to negatives. It's going to apply to this coefficient also. So this exponent only goes directly what's in front of it unless there's parentheses. Okay, so this is going to be 6 times the 4th root of x to the 7th. Okay, do I box it and I'm done? I can simplify this. I have 7 x's and I really need groups of 4, right? So this becomes 6 what? Then the 4th root of x cubed. Always check to simplify. Okay, now when I'm dividing, I have 6x divided by x to the 3/4. Okay, I didn't write my x big enough for that to look like an exponent, but that's an exponent. Okay, so x and x, this is a 1. So I'm still going to do 1 minus 3/4. So that's just going to give me 6x to the 1/4. So my answer is just 6 times the 4/3 of x. You're subtracting, so if these are like bases, you're taking care of it right here, 1 minus 3/4. So if I had x to the 5th over x squared, that becomes what? X to the 3rd, because you're doing 5 minus 2. So the same thing, I just have a fraction. What other questions do we have? None? Okay, compositions of functions. They can be written different ways. It can look like this, and it's read f of g of x, or this, which is still f of g of x. It's read the same way, it's just written different ways, okay? All of that, you're working inside outward, okay? So, compositions of functions, composite functions, it's all the same thing, okay? I'm still giving you functions. So, f of x is equal to x minus 4, g of x is equal to x plus 8, okay? This is telling me I'm finding f of g of negative 4. So I'm going to find g of negative 4 first. I start inside out, okay? So g of negative 4, I'm plugging in negative 4 for x. So I have negative 4 plus 8, which is 4, okay? So g of negative 4 is 4, so then I'm finding f of that value, which is 4. Okay, so I found g of negative 4. Y'all follow me? And so I'm plugging that in, so it's f of 4. So 4 minus 4, f of 4 is equal to 0. Okay? So then I'm finding g f of negative 3. So I'm going to find f of negative 3 first. So negative 3 minus 4, which is negative 7. So g of that value, negative 7, is equal to negative 7 plus 8. So g of negative 7 is equal to 1. Very simple when you have functions like that. Are you going to always have functions this easy? No. Okay, so now if f of x is equal to x squared plus 1 and g of x is equal to 2x and h of x is equal to x plus 2, we're going to first find f of g of 3. So I'm going to find g of 3. So that's just 2 times 3, which is 6. So f of 6, I'm taking 6 squared plus 1. 6 squared is 36 plus 1. F of 6 is equal to 37. Okay. Now I'm finding f of g of h of 2. So what am I finding first? H of 2. Okay, h of 2 is 2 plus 2, which is 4. So then I find what? G of 4, 2 times 4, 8. So now f of 8. So 8 squared plus 1, f of 8 is equal to 65. Y'all good with that? Do we have questions? Okay, if f of x is equal to x squared minus 4 and g of x is equal to 4x minus 1, find f of g of x. Now it's not a value, okay? It's just f of g of x. So all I'm doing is I'm taking g of x, which is 4x minus 1, and I'm replacing x with that. So f of 4x minus 1 is equal to, replace x with 4x minus 1 and square that, minus 4. Okay? So what is 4x minus 1 squared? 16x squared minus 8x plus 1. It is not 16x squared plus 1. I am not just squaring this and squaring this. If you cannot get to this in your head, if you don't know the formula, then you write 4x minus 1 twice and you FOIL that. Then I have minus 4. So f of 4x minus 1 is equal to 16x squared minus 8x minus 3. Do we understand that when it's a function? Okay. If f of x equals 2x to the negative 1, and g of x is equal to 3x plus 5, and h of x is equal to x minus 6 divided by 2, find each of the following. Alright, f of x. So I'm taking what f of x is and plugging it into itself. So I'm taking f of what? Okay. So I have 2 times, in parentheses, 2x to the negative 1 power, all raised to the negative 1 power. Okay? What am I going to do first? Anytime I have multiple terms with an outside exponent, I distribute that outer exponent. So 2 times 2 to the negative 1, x to the positive 1 now. Okay, well this is just 2 times x over 2, right? Because that negative exponent tells me I need to flip it. So f of 2x to the negative 1 power is equal to x, because those 2's cancel. Do we understand that? Okay. Alright, h of x. So that g of x isn't even used. So sometimes I might give you more than what you need. Okay? So I'm now doing h of, very good. So I'm plugging in the entire x minus 6 over 2 for that x, and then minus 6 over 2. Okay? I want to make these common denominators so that I can clean up the numerator. So if I need this to have a denominator of 2, it's x minus 6. This turns into 12 over 2. So minus 12. Right? 6 is the same as 12 over 2. So my numerator of the numerator is x minus 18. Well, x minus 18 over 2 over 2, what is that going to turn into? X minus 18 over 4. Well, how did we get that? Well, if you remember, keep, change, flip, 2 becomes 1/2. There's my 4. Okay? You're going to have to be careful on some of them. Some of them are going to get messy, and you have to really pay attention to your work. Do we have questions over that? Okay. Okay, that was your composite functions. Now we're going to talk about iterations. Okay, so a special type of composition is a function within itself. Okay, tessellations are formed by these iterations. Okay, we could do a project over that, but we're not. So find the first 4 iterations of a function given its initial value. So this is my formula for the iterations. And it tells me find f of 4 if f of 0 is equal to 2. That's my initial value. Okay, so n is like the position in that iteration. It's like an x. Okay, so if I know f of 0 is equal to 2, that 0 is my n. So I'm going to be finding f of 1 by using that previous value. Because f of 1, if I plug it in here, is f of, my n is 1 minus 1 plus my n, which is 1. Okay? Well, what's 1 minus 1? So f of 0 plus 1. What's f of 0? 2 plus 1. So f of n minus 1 is just telling you your previous term. Okay? But it's not always going to be n minus 1 necessarily. What I give you is, but you might not always be given that. Okay? So this is 3. So f of 1 is equal to 3. So then f of 2 is f of 2 minus 1 plus what? 2. Alright, so that's f of 1 plus 2, which is 3 plus 2, which is 5. Okay? So f of 3 is f of 3 minus 1 plus 3. So f of 2 plus 3. F of 2 was 5 plus 3, which is 8. So f of 4 is f of 4 minus 1 plus 4. So f of 4 is equal to 12. Okay. Find the first 4 iterations of a function given its initial value. F of n is equal to f of n minus 1 plus 2n. Find f of 3, even though it says find the first 4, we're going to find f of 3 if f of 0 is equal to 7. So f of 0 is equal to 7. F of 1 is f of 1 minus 1 plus 2 times 1. So f of 0 plus 2. 7 plus 2 is 9. So then f of 2 is equal to f of 2 minus 1 plus 2 times 2. So f of 1 plus 4, 9 plus 4, which is 13. So then f of 3 is f of 3 minus 1 plus 2 times 3. F of 2 plus 6. So f of 3 is equal to 19. Make sure you answer it with what your instructions is telling you. It's telling me to find f of 3, so f of 3 equals 19. We good with that? Do we have questions?